Today, I'm going to talk about the present and future of network security platforms based on ZTNA. Honestly, I gave this session a grand title, but in the end, ever since I joined AhnLab, I've been doing product management for network products, and I've always approached things entirely from a network perspective. While thinking about what to explain to our customers, I decided to talk about how network security platforms are currently focused on zero trust, which is a hot topic, and also discuss the direction of AI-related network security platforms going forward. To briefly talk about the current trends, as mentioned in the previous session and also in the keynote this morning, and even frequently in recent news, we often come across incidents involving ransomware or malware infections. In most cases, these incidents involve ransomware, but if you look closely, one thing that always appears is SSL VPN. Since I work in networking and view things from a network perspective, I've noticed that SSL VPN is frequently used as an attack vector for malware or ransomware infections. So, I'd like to explain this part in a bit more detail. As I mentioned earlier, among network security products, SSL VPN is the most commonly used attack vector in cases of malware infection. This isn't just an issue in Korea. Global vendors are also affected. And the reality is that they haven't been able to escape from being exploited. As you can see, these are VPN solutions from well-known vendors that anyone would recognize by name, but vulnerabilities have been discovered in them, which have been exploited in attacks, and in some cases, have even led to significant damage. And if you look at just the vulnerabilities themselves, it's not just one particular vendor solution. Vulnerabilities are cropping up in products from a wide range of vendors. There are even extremely serious vulnerabilities with a CDSS score of 10. If you look at the registry on the right, most of these vulnerabilities were registered this year. This site is the NDD site operated by the US NIST. Here, when I simply searched for security vulnerabilities related to VPNs, as you can see on the right, about 780 results came up. In fact, there are so many VPN-related vulnerabilities being discovered and exploited that they fill up an entire page like this. So from a network perspective, we need to consider why SSL VPNs have so many vulnerabilities and why they are so frequently used as attack tools. There may be several reasons, but if we pick the two most important ones, first, due to the nature of SSL VPN solutions, they are positioned at the very front of the internal network and serve as gateways from the outside, making them very attractive targets for attackers to go after. And due to the nature of appliance products, patch management is extremely difficult. Since patches are usually not applied immediately in order to maintain service continuity, these systems remain exposed to vulnerabilities for long periods, making them frequent targets for attacks. This isn't just a theoretical issue. According to a report from a major global vendor, these statistics are directly mentioned, reflecting the reality of the situation. Based on what I've just said, SSL VPN might seem like a very vulnerable and risky solution, but if I were to ask all the customers here whether they could do away with SSL VPN, I doubt a single person would actually be able to remove it. That's how essential this solution is for companies and organizations today. Especially with the rise of cloud computing and the shift to remote work after COVID, SSL VPN has become an absolutely necessary solution, one that can't be eliminated or replaced. That's just the reality. So instead of trying to replace SSL VPN, we thought about how we could use it more securely, how to make it safer. We found the answer in Zero Trust. In the AhnLab Network Security Platform, Zero Trust is implemented as ZTNA through our firewall product, XTG. Just like the architecture mentioned in Zero Trust Guidelines or the US NIST standards, you need one XTG device that acts as the ZTNA manager, fulfilling the PDP role. And below that, you have gateways that serve as PEPs. The XT devices can be configured as a single unit or as multiple units. And through the ZTNA client we provide, users are able to access internal company resources. In that process, instead of connecting directly to the resource through the gateway, the connection first goes through the manager, where authentication is performed. Only devices that pass the manager's authentication policy are allowed to communicate through the gateway. This is the basic, lightweight ZTNA structure we provide. In addition to this, by integrating with widely used endpoint products like the 3 EPP, ESA, as well as EDR, XDR, TIP, and SOA solutions, we are able to further strengthen our intelligence and establish a more robust response system through expanded integration within AhnLab's own products. From a network perspective, this allows us to provide even more powerful ZTNA functionality. We tell our customers that adopting ZTNA doesn't require bringing in an entirely new solution. You just need to add one manager device to your existing firewall setup. There's no need for major changes to your current infrastructure. And since it operates based on the firewall equipment you're already using, we explain that you can implement ZTNA easily and quickly. So today, I'd like to show you our AhnLab XTG UI directly and walk you through the steps involved in setting up ZTNA using AhnLab XTG. First, this is the login screen that appears at the very beginning. When you log in as an administrator here, since this is a newly released product, most of you probably haven't seen it yet, our dashboard will appear first. From here, you go to the System menu and start by configuring the certificates. These certificates are also used for the integration between the ZTNA Manager and the gateway, and users will install this on their devices to follow the ZTNA policy and get authenticated by the manager. So, you can either register a private certificate or insert an external CA certificate to configure it. Once the certificate is set up, the next step is to add users who will access internal resources using ZTNA. At this point, this user object isn't exclusively for ZTNA since we're dealing with a firewall. It's a shared object that's also used in general firewall policies and SSL VPN policies. That's why, as you can see at the bottom, you must make sure to check the option for ZTNA usage. Once you check that option and create the user will be added to the list like this. Next is the configuration process for the manager. When setting up the ZTNA manager, you will configure the interface and access port of the device to be used as the manager, as well as the certificates. Next, to fulfill one of the most important roles in ZTNA, which is continuous status monitoring, you need to set how frequently information will be collected from the device. As you can see on the screen, it's currently set to 60 seconds. If the administrator wants to enforce a stricter ZTNA policy, you can shorten the interval to as little as 5 or 10 seconds. After configuring the manager like this, you then create what's called a ZTNA profile in the manager. To put it simply, a ZTNA profile is basically a ZTNA policy. In the initial step, you just enter a name and description to create the profile. Next, when you click on Edit Profile, you'll see a screen like the one shown here. Yes, as I mentioned, the ZTNA profile is essentially a policy. It's the policy that determines what conditions a user must meet when they request access to internal resources through their device, and whether or not access will be granted. Today, since I'm doing a demo, I've set it up simply so that it has to be a PC running Windows 11 or higher. V3 must be installed, the engine must have been updated within the last day, and real-time monitoring must be enabled. The ZTNA profile created like this will actually operate in conjunction with the firewall policy I explained earlier. Next, we set up the gateway. As you saw earlier, the gateway needs to be linked with the PDP manager device, so you set it up using the manager device's IP, port, and certificate. If the communication is working properly, the manager's information will be updated as you can see at the bottom. And if you go to the manager device, you will see that the connected gateways are listed under the Connected Gateways tab like this. The manager and gateway don't have to be configured one-to-one. A one-to-many setup is also possible, so this list could get even longer. And as I mentioned, AhnLab XTG is a firewall product. That's why all policies operate based on firewall policies. So, you set up the necessary objects, whether it's a host, FQDN, or user object. For the source and destination, establish your firewall policy, and then, as you can see in the middle, go to the detailed settings where there's an option for ZTNA integration. If you link the ZTNA profile you created earlier there, only the devices that meet the requirements of that profile will actually be able to use this firewall policy. Next, you need to distribute the client to the end users who will actually be connecting. When you connect to a specific port on the manager device, you will be directed to a page where you can download the client. After downloading it here and going through a simple installation process, you'll have a client with a straightforward UI running like this. To connect from the client, you first need to add the ZTNA Manager server. Simply enter the name, IP, port, and certificate, and it will be managed in a list like this. Here, you select the ZTNA Manager server you want, and when you connect, authentication is performed using the ID and password you entered for the user object created in the previous step. Once the connection is successful, you'll see an icon indicating connected to ZTNA like this. When a device with a client installed connects to the manager, it will be displayed like this under the device list screen in the manager. Each one of these represents a device connected to the ZTNA. This screenshot is actually from our company's internal environment, so I blurred out the user section since it showed the names of our employees. I only left my own name visible, and if you look to the left of my name, you can see that 2 ZTNA profiles are matched there. So, as I mentioned earlier, you can link one ZTNA profile to a single firewall policy, and a single profile can be included in multiple firewall policies. Therefore, any firewall policy linked to a matched profile can be accessed through that profile. Here, the device information is also displayed by default. Although this isn't a live demo, let me briefly show you the test environment I used. Earlier, I set up the ZTNA profile to include whether v3 is installed and real-time monitoring as part of the ZTNA policy. In this state, my PC is actually connected to the ZTNA, and real-time security monitoring is enabled. If I forcibly turn this off, you'll see that the ZTNA profile that matched in the device list screen disappears, even though I authenticated with the manager. Since my status no longer matches the ZTNA profile set in the manager, I can't pass through any firewall policies, and in reality, I can't access internal resources through the gateway. And by setting up and operating ZTNA like this, you can also analyze traffic. We're showing traffic under various conditions, and in those situations, we're also displaying information about threats. Up to this point, I've shown you the actual UI and demonstrated how to configure ZTNA, including the procedures involved. If you go to the booth outside, you'll see that a demo environment has been set up in a similar way. I think it would be good for you to check it out in person. So, I briefly explained how to set up the basic configuration, and I prepared 2 cases where it would be good to use ZTNA. The first case is the most common scenario that comes to mind with ZTNA, remote access. Usually, when we think of remote access, the first things that come to mind are working from home and environments that use SSL VPN. As I showed earlier with the architecture diagram, authentication is done through the manager, and the gateway essentially acts as the SSL VPN server. In that segment, devices that have passed authentication by the manager can access internal resources through the gateway. In the case of remote access, You could also say that IPsec VPN is a form of remote access as well. Since the communication method is gateway to gateway, a tunnel will already be established. But if you want to implement ZTNA-based access control for employees at a branch office, you would have them install the client as well. And by applying the same ZTNA policy, they would first go through authentication by the manager. Only employees who are authorized through authentication will be able to access internal headquarters resources via the IPsec VPN tunnel. So far, I've only mentioned remote access while explaining a simple case. But as shown earlier in our demo environment, the same approach can be used within the internal network as well. In fact, with an even simpler setup, users can easily configure it just by installing the client. Also, with the new WireGuard-based lightweight VPN developed by us at AhnLab XTG, or with agentless SWG-based web access, Zero Trust can be applied through the same flow. As I just mentioned, regardless of how the gateway in front of the resource that the actual user and device want to access is connected, as long as it goes through the authentication mechanism via the manager, Zero Trust-based access control is possible. As I've been saying, ZTNA can be configured using only Firewall XTG, and all the communication methods I just mentioned, SSL VPN, IPsec VPN, and even LWVPN, can all be set up using only XTG. So, regardless of the communication method, Zero Trust-based access control is possible. The second case is a network separation environment. In fact, along with Zero Trust, this has become one of the hottest topics recently. When you think of a network separation environment, most people probably immediately think of the N2SF mentioned in the National Network Separation Policy. In N2SF, Zero Trust is directly mentioned as one of the solutions to ease network separation. So, I briefly showed that you can actually use Zero Trust to convert physical network separation into a form of logical network separation. While explaining this part, I also want to give a brief explanation about N2SF. Coincidentally, yesterday at the Youn building, there was CSK 2025, and during one of the afternoon sessions, the National Intelligence Service gave a presentation on the official version of the N2SF 1.0 guideline. Since the guideline hasn't been distributed yet, today's presentation will be based on the previously released draft version. The National Network Security System looks complex, but simply put, it's a framework. The key part is the 6-step process at the bottom, which has 5 procedures and a security review by the National Intelligence Service. Focus on that. This diagram is a simplified version of the process. In the end, N2SF is about the fact that, under the current network separation policy, it's difficult to access the internet. So in order to allow the use of services like AI or cloud on the business network, the government classifies the importance of its systems and tasks into 3 levels: confidential, sensitive, and public. Then, security control policies are applied differently according to each level of importance. As I mentioned, it's necessary to apply appropriate security controls based on the grade of the information system or service. For example, if a business network previously had no internet access, but now, with N2SF, internet access is possible. In this case, the business's importance would be classified, and if a specific level among the 3 stages is defined, the corresponding security controls for that level would be attached on the right, as shown here. So, in N2SF, if all these security control measures are satisfied, it means that even a business network PC can be connected to the internet externally. That's the idea you should keep in mind. So, I've noticed that a lot of customers actually find N2SF quite difficult. That's because, even in the draft version, there are about 180 security control items, and there's talk that the official version will have around 250. Since there are so many items, I've seen many customers struggle, not knowing what to do with all those requirements. So at AhnLab, we organized and provided information on which of our various solutions satisfy the different security control items in N2SF. And the table you're looking at now lists the security control items that are met by our firewall product, XCG, which I mentioned earlier during the Zero Trust explanation. We defined and laid out which requirements the product fulfills. So far, I've given a brief explanation about Zero Trust and N2SF. But earlier, in the title, we mentioned the present and future of network security platforms. Some organizations have already adopted Zero Trust and N2SF, and N2SF is currently being implemented in some places. Many organizations and companies are also considering adopting Zero Trust. And since we can offer you the option to implement it right away through our XTG product, we've referred to this as the present of network security platforms. For the future, since today's ISF theme is also about AI, I'd like to briefly explain how network security platforms might evolve by integrating with AI and what direction they could take. First, AhnLab's network security platform is named Network Plus. In reality, it consists of 4 products, but by separating ZTNA as an independent solution, it is structured as 4 products and 5 solutions. As I mentioned earlier, our ZTNA is implemented through a firewall product, but it operates in a completely different way from traditional firewalls. And since it was developed as a specialized feature, you can consider it as a separate solution. Now, I'll briefly show you how AI can be applied to AhnLab Network Plus, which is structured this way, before moving on. First, looking at the firewall, actually, the firewall was briefly mentioned in the keynote as well. In the case of large enterprises, there can be tens of thousands of firewall policies being maintained. Every day, dozens or even hundreds of policies are deleted, removed, or added, with policy changes happening very frequently. That's why, in this kind of situation, optimizing policies to operate equipment efficiently becomes extremely important. We're aiming to help administrators with this by leveraging AI. Also, for the various IPs, URLs, and domains used in firewalls, our infrastructure AhnLab already has AI integrated into the infrastructure. So AI is analyzing this information, and the analyzed databases are already being received and applied by our products. Lastly, moving beyond legacy firewalls, we're now going to use application firewalls. In fact, even just in the field of AI, hundreds or thousands of services are already emerging. In such a situation, it's difficult to fully establish firewall policies using only predefined applications. That's why, in the process of identifying whether something is an application or a service, we plan to use AI to quickly determine what kind of application or service it is, and then apply that to the firewall policies. There are also various functions in IPS. The most important thing is that, while signature detection is currently the main function of IPS, it also provides a variety of other features to detect threats. But among them, the most important is, of course, zero-day attack detection. Even in situations where there is no signature, we need to be able to quickly identify new threats, detect them, and provide functions to defend against them. We believe there are limits to doing this manually, so we're looking to leverage AI to help with this. And in the case of anti-DDoS products, they are the ones that stand at the very front among network security products, taking on DDoS attacks entirely on their own. The key to DDoS defense is quickly identifying and defending against or diverting attacks by analyzing traffic and setting appropriate thresholds based on that analysis. That's why AI will be applied to areas such as automated mitigation systems and intelligent traffic analysis. As I explained earlier, ZTNA monitors user and device information and performs access control based on that, so optimizing these policies is extremely important, and even the process of administrators establishing these policies can be very complicated. You have to set up ZTNA policies in a very detailed way by applying a variety of conditions, and even after that, when a permitted device connects through the gateway, you need to break down the firewall policies as much as possible to the level of microsegmentation and input them accordingly. That's why we believe policy optimization is the most important aspect here. And another thing is that we are working on using AI to learn the access patterns of users and devices, and then leveraging that to optimize policies and provide policy recommendations. This is part of our effort at AhnLab to build an AI-based autonomous security operations platform. Lastly, when it comes to TMS, which centrally manages the policies and event logs of network products. Unlike other security devices, TMS collects events from a wide variety and large number of devices. Because of this, it can create scenarios by correlating security threats and incidents across different devices. Based on these scenarios, AI can optimize or recommend policies, and by analyzing the vast number of collected event logs, it can perform correlation analysis to detect complex attacks. Ultimately, we aim to enable automated responses as well. I gave a quick explanation just now. I explained how AI is being used or planned to be used for each product. Some of these features are already implemented and working, and as I mentioned earlier, things like URL or IPDB have already been fully applied. So, you can think of what I just explained as the future that AhnLab's network security platform is aiming for. As was repeatedly mentioned in the keynote earlier, we are establishing the direction for the network side to achieve AI-based autonomous security operations, and I hope you understand that we are developing things in this way. Network Plus is not just about creating scenarios within the network product and stopping there. Going forward, although there are already some integrations with endpoint products like the E3, EDR, EPP, and NDS, we are working to create even closer connections so that we can generate various synergies through tighter integration. And on top of that, by integrating with XDR, TIP, and even SOA, as I mentioned earlier, we are working to strengthen threat intelligence, manage asset risk, and further expand to automated response through SOA. And finally, by integrating with AhnLab AI Plus, we are working to make it a key pillar for agentic AI, optimize your security operation, which is also the theme of this ISF. I hope you'll show a lot of interest and look forward to what's coming. We've just hit exactly 30 minutes now. So far, I've quickly explained what the current network security platform based on ZTNA can offer, and the direction AhnLab's network security platform will take in the future by integrating with AI. Once again, I hope you'll show a lot of interest and anticipation for our network security platform. And I'll wrap up this session here. Thank you.